Okay, I'm going to work on problem number 16 here. Problem 16 has two parts. Let's start with part A. In part A, it describes that we have a soapbox derby, non-motorized cars racing down a slope tilted 14 degrees below horizontal. So let's go ahead and draw that. So here's my slope. It says it's tilted 14 degrees below horizontal, but that means this down here is also 14 degrees. So we'll just use this angle. So here's my, I'm going to erase this for neatness. So here's my little car sitting on the slope. So I'm starting with a velocity equal to 0, and I want to know what is my velocity when I get down here to the bottom of the slope. Now what do I know? I know the total length of the ramp. I know that this car is going to travel a total length of, they say, 57 feet. But ultimately I need to put in my units in SI, so let's go ahead and convert it right now, and they give me the conversion there. 3.28 feet per meter, which if I multiply that out gives me 17.4 meters. Okay, so this is like a free fall problem again, except I'm at a slope. I'm starting with a velocity of 0. Instead of being perfectly vertical, being dropped off a cliff and falling down, I'm sloped a little bit. So I'm going to solve it generally the same way, only this time I just don't know what the acceleration is. That's the first thing I need to calculate. Let's draw what the curve will look like though. I know that I'm going to start with a velocity of 0 because I'm at rest, and under the influence of whatever acceleration I calculate, my velocity is going to increase. It's a constant acceleration, so I'll increase at an angle here linearly, and I know the angle here is acceleration, so I just need to find what that acceleration is. Alright, so how do I calculate that? Well, here's my car. Acceleration due to gravity is pulling directly down, but I want to break it into its components, parallel to the ramp and perpendicular to the ramp at the angle of 14 degrees. So this is my, okay, I'll call it AX, and this is my AY, and this is my A. So ultimately I'm looking for AX because this is the only component of acceleration that contributes here. So this is going to be AX. Alright, so let's do the math here. As we've done a few times before, I know I'm looking for the one opposite, so sine of 14 degrees equals opposite over hypotenuse. Rearranged, I know I have AX equals A sine of 14. I can plug in my value of A, I know is 9.8 meters per second squared, times sine of 14. And if I do that math, I've already done it, I end up with approximately 2.37 meters per second squared. They ask for it to 2 significant digits, so I would round that to 2.4 meters per second squared. So that's part A. Now I know the acceleration, 2.4, that I can take and put on this chart up here. So I know my acceleration equals 2.4 meters per second squared. Now let's go on to part B. On part B, they are asking what is the velocity at the bottom of this ramp. So let's think. I know, so basically they're asking me to pick some point right here until, I know my initial velocity is 0, but what is this velocity right here at some time? I don't know how much time has passed. I do know acceleration. I do know my initial velocity, and I want to find my final velocity, but I do know distance. I know that I'm going to travel a distance of 17.4 meters. So this is like back to chapter 2. What equation do I know for constant acceleration that will relate acceleration, velocity, and distance? Well, here's my equations for constant acceleration. And this is the one I want because this relates velocity, acceleration, and distance. So let's write that equation down. So I'm going to say v final squared equals v initial squared plus 2 acceleration delta x. Okay. Now my v initial, of course, goes to 0 because I'm starting from rest. So what am I left with? I'm left with vf squared equals 2a delta x. Remember, I'm solving for velocity, so I'll just take the square root of both sides. Now I can go ahead and substitute in. What's my acceleration? I already solved for that in my previous problem. Multiply that times my distance. What's my distance? They gave me 57 feet and I converted it to meters, so I have 17.4 meters. Calculate that and I end up with approximately 9.14 meters per second. They said 2 significant figures, so that'll be about 9.1 meters per second.